Okay, hopefully with the question on the board, you would be able to spot that integration by parts. Okay, so integration by parts would be the way forward. And we know that that means that generally when we integrate something of the form u dv, that means a piece that we consider sort of differentiating and a piece that we consider integrating, that it fits this rule. Okay, so that's all well and good, but I'm going to show you some increasingly long questions. So here we can use a shortcut called the tabular method. Okay, tabular method is a shortcut for doing the questions. And I'm going to show you how I sort of make sure that I don't make silly mistakes when I do this. So let's just start off doing it properly, and then we're going to use the tabular method. Okay, so u equals dv. This is how I like to set up to start with. So u is going to be according to that sort of trick of LATE. Late is a tool to help you think about which piece to choose as your u piece. Logs, algebra, so algebra in this case. Trig, exponentials. That means I'm going to make this piece here 2 to the x. We then consider this piece sort of the differentiated piece. I'm going to call it just du. You don't need to write du, dx, dv, dx. You don't need to do that. And this is the piece to think of as sort of integrating. Okay? So something like that. Well, if we substitute them into the rule says uv minus the integral of v du. So that would give us sort of a result where we end up using pieces like this. So it would give us half e to the 2x times x. So let's put the x there. Half x e to the 2x minus the integral. So something that we still have to work out. Well, that's a 1 time, so that's relatively convenient. It would give me that result there, yeah? And I'm going to write that result again, now doing this integration over here, because this should become minus a quarter e to the 2x. Test it out, it works, okay? So it would be that plus c. Okay, the c is important sometimes. I've seen it on some mock papers, you actually get marked down for not putting the c, so still a good idea to do it. So, okay, that's fine. That's all well and good. But let's have a look at a different way of doing it now. So I'm going to start by doing these pieces here. And I'm going to start in a similar way to how I began by writing these pieces here. So I'm going to write this as the u column. And I'm going to write this as the dv column. Now, there's all kinds of variations on this online. This is just how I like to write it. And I also sort of do this to check that I'm using my own version of the table properly. So u was x and dv was e to 2x. So over here, we are going to differentiate. Over here, we're going to integrate. So what do I mean? Well, let's differentiate x. So there's a 1, and then, well, you know, there's a 0. There's nothing there. So I'll just put, I don't know, a little dash like that, maybe. Over here, we're going to integrate on this side. So a half e to the 2x, a quarter e to the 2x. You know, we could do more. We might not need to use it, though. So how could I use this now to get the result that I already know is correct from down here? Well, this is u, this is dv. That's not in the rule. In the rule is uv. So I'm going to do like this. I'm going to do uv. So that gives me my first piece. Notice that's the same as this piece here. Now, I could stop. One way to use this method is to stop. So if you, if you do what you've done so far I have half x e to the 2x, right? Well, if I want to stop because I have a difficult question or something confusing, and that will happen on some of them, all you do is you do a horizontal line. So if you do a horizontal line, you just take that sign there and you write it with an integral. Okay, so notice again, that gives me the same result as on this line. But this method's more powerful than that. So instead of doing that, I'm not going to do a horizontal line. I'm just going to keep doing lines like I had on here before. So there we go. Now what's that? That's telling me to do minus a quarter e to the 2x. Notice that's that result there. Well, you might think then, well, how do you know to not keep going? Well, the table will tell you. Well, that's a 0, isn't it? So I need to stop then when I've got that situation, because there will be a 0. So this method here, this is called the tabular method. So we're going to have a go at this now on some questions that would take us otherwise a little bit longer. And like I said, everybody has a slightly different way of doing this. I like to write in my original pieces at the top and sort of do it like that. That's the way that I like to do this method. So let's have a go now on something that requires it 2 times or maybe even 3 times. So I'm going to write my x cubed in my u, that's my differentiation part. And I'm going to write my dv as the top one, which will be e to the 3x. That will be my, that will be my integration part. And I'm going to work down here. So 3x squared, what's that? That's 6x, the number 6, and then there's a 0. Over here, so integrating up, you have to compensate for the 3. So you'll be saying a third e to the 3x, a 9th e to the 3x, a 27th e to the 3x. Let's draw some horizontal lines just to keep an eye on where everything is. Let's do one more. So what would that be? That is, what we're doing, 3. So that's an 81, isn't it? 81 e to 3x. Right, let's see if that's enough. So the way we were doing it before, when we do this, this is uv. So this is the one just to get correct, really, to be really careful with. So uv is going to be that, and then we would hit our 0. So just like that, we'll actually answer the question. So it's going to be 1/3 x cubed e to the 3x minus 3. 3 and the 9 go together, don't they? So shall we simplify? Shall we say minus 1/3 x squared e to the 3x. Why are the signs alternating? It's because of the sort of double negatives that you would get by doing integration by part. That's the long way. Next is a 6/27. I'm being slightly careful of simplifying too much in my head. So that's going to be a 2/9 x e to the 3x, and hopefully we're almost there. So minus a 6. And yes, I could simplify, but, I leave that for you to do afterwards. 6/81 e to the 3x plus c. So what do you think? Okay, there's a reason why we're calling this a lightning skill. If you have to do integration by parts twice, 3 is really very, very unlikely, I would say. But if you have to do it twice, okay, you may find that the tabular integration method is the way for you.